Hello, everyone. I would like to talk to you guys about difference quotient. This is a graphical representation of what we're going to speak of for the difference quotient. But to simply say what a difference quotient is slope. It is the slope of a curved line at a specific point on that curved line. And this is how we find it, by finding the slope of a secant line. So let's talk about slope again. Remember, slope is a ratio of change. The change in y's over the change in x's. Change in y's, the change in x's. Slope is a quotient. It is a division problem. Therefore, slope is a difference quotient. Difference, subtraction, quotient, a fraction. So with our curved line given here as f of x, I need to find 2 points on that line and draw a line connecting those 2 points. That is the definition of a secant line. Intersects a curved line at only 2 points. And once I know those 2 points, I find my slope, the difference in the y's over the difference in the x's. But we're going to write this differently, because instead of using our y's, we're going to use function notation. X's stay the same, so this will be my first point, x. This is my second point on the x-axis, x plus h. I've increased from x by h, so I've said plus h through here. X is the independent, or the input, so whatever I put in, that's what I'm going to get out in function notation. So this coordinate right here is simply x comma f of x. My second point is simply x plus h plugged into function notation. Those are my 2 points. And then I plug them in, especially the function notation, in lieu of my y sub 1 and y sub 2. And combine like terms. My x's in the denominator cancel out. That is x plus h minus x. My x's cancel, leaving me only with h. And here it is written, the difference quotient. And it is, again, this is nothing more than being in function notation. This is my difference in y's, or my change in y's, and this is my difference of x's, or the change in x's. So I want to talk to you about curvature. And to be able to tell you, curvature really is about perspective. It's how are you looking at something. So it's easier to just be able to view it than to turn around and be able to talk to you about it. So again, this is Desmos, and it's online and it's free. So here we have us, a line. But if I were to zoom out, can you see what's happening at these ends? I'm starting to get some curvature. And the further and further that I zoom out, I'm changing my perspective of that graph. I went from what looked like a linear equation to a quadratic equation just by my perspective. And I can see here definitively there's curvature. But whenever I was zoomed in, it looked like it was a straight line. If I were to intersect this graph, even though it's curved, with the secant line and hit 2 points and hit them very close together, it would almost be a straight line. That secant line would be a very good representation for that curved line at that point. So let's take that to something that I think that we can all understand and see. If I were to take a basketball and hold it in front of me, I could look at that ball and move it around and say, this is curved. But, and that's because of our perspective. Mainly it's because of our size compared to the basketball. Because in the other example is saying, if you just walked out there outside and you looked at the horizon, no houses, no trees, nothing. Like I like going to the beach and just looking at the ocean. Whenever I look out there at the ocean, I do not see curvature. Let's see a straight line. It's about perspective. I am minuscule. I am so small compared to the earth that as I walk, if I walked 100 miles, unless I hit a little hill or something, I can't discern that I'm actually walking over a curvature because I'm so small. Okay, so with that being explained about the perception of curvature and being able to see it on that graph, how I could zoom in, this is how we can be able to say this is the slope of this curved line at this point. And that's one of the premises of calculus, being able to do this. So what I would like to do is be able to look at an example, okay? One in which we already know the answer as soon as we look at it. Because what did I tell you that uh, the difference quotient is? It's just slope. So you should be able to look at the equation I've given you and already tell me what is the slope of that. What kind of equation is that? Linear. So you should be able to say, okay, I know the slope. The slope is 4. Well, then let's actually work it. That's one of the nice things in math, that no matter how the problem is, I should be able to work this and solve it. So what I'm going to do is I'm going to look at x and f of x up here in this, and I'm going to plug in. So my first one, I need to substitute x plus h into my function everywhere there is an x. So I have 4, and instead of x, I'm going to write x plus h minus 1. That is this right here. Minus f of x. Well, that's just what I'm given. And I'm going to put that in parentheses. I'll have to distribute that over h. What we did is one of the hardest things that you have to do is make sure that you're just substituting in x plus h for x. Now I combine like terms. Well, I'm going to get rid of these parentheses. I'm going to distribute my 4 through there. So I'm going to say f of x plus 4h minus 1 minus 4x plus 1 over h. Now I'm going to combine like terms. So I have 4x minus 4x, they cancel out. I have a negative 1 plus 1, they cancel out. I'm left with 4h over h. My h's cancel. I am left with 4. That is the slope. And it was already there. We understand slope-intercept form, and the coefficient with x is my slope. So let's work one that's just a little bit harder, okay? So f of x equals a negative 1 over 4x. Again, I'm just going to start plugging in here. So my first thing I have to do is I'm going to replace x with x plus h. So I'm going to have a negative 1 over 4 times x plus h. Okay, that was this function notation here, minus a negative 1 over 4x. That was f of x. And I put everything over h. Okay, so I have a fraction over a fraction. So the first thing I have to start looking for is common denominator. Well, I need to simply multiply these two together to get that common denominator. They already share 4, but this one has an x plus h and this one has an x. So I need a common denominator. And how I create that is I'm going to multiply this side by x plus h. And I have to do what I do to the denominator, I have to do to the numerator. So think about this. X plus h over x plus h is simply 1. I'm not changing that fraction. And this one I'm going to multiply by x. Whatever I do to the denominator, I must also do to the numerator. And x divided by x is simply 1. So I'm multiplying these two sides to create a common denominator. So I end up with a negative x over 4x times x plus h minus a negative x minus h over 4x times x plus h. Again, everything over h. 4x times x plus h, I'm going to keep it just like this because this was the whole goal, was to get those the same. If I have a common denominator, then I can write my numerators as those are together over my common denominator. So I have a negative x minus a negative x minus h over 4x times x plus h over h. I'll make it. Now I'm going to combine my like terms in my numerator by distributing that. So a negative times a negative, well, really that becomes a positive and that becomes a positive. My x's will cancel. A negative x plus x, simply 0. So what I have is I have h over 4x times x plus h over h. Dividing by a number is the same as multiplying by its reciprocal. Dividing the same as multiplying by reciprocal. That's keep, change, flip. That is keep, change, flip. So what I actually have here is h over 4x times x plus h times 1 over h. H's cancel, and what I'm left with is this. That is my slope. Okay guys, make sure you're watching the videos from the publisher. When you're working your problems, you're structuring everything, you're thinking it out. That's the nice thing about math, is that everything is building upon it. Everything that you learned previously, look, we're putting in there. Function notation, slope. We go back to it, we work through it. Okay, so structure your problems, think about them critically, and good luck on your homework.